I have to admit that I realized after going back to the office that our class, I went very fast with our class. So other classes are still trying to finish this topic, but we are actually almost at the end. So we are going to slow things down a little bit.
Oh man, don't slow things down. You must go faster.
That's not how relationships go. Yeah? Slowly build up the trust. Okay, so what we are going to do is that rather than have you have homework at home to do, yeah, then we will do some of your homework in class, and I will go through class. What do you want to do instead?
Yeah, it's for doing on the MRT train.
Yeah, but I didn't book the lab today. Okay. Next week, since we are faster, right, I can put more labs. Okay? Then we'll go in to do some out of the lesson kind of experiments. Okay? So, but we go apart also lah. Right? We still have homework to do. So, since you are a bit faster, then we'll do some in class, we go through class, then you would want to do this additional science work at home. Okay? These are very funny kids, huh? Like, more homework, some classes, they scream and whine. This class want to.
What do I do at home?
Don't you have other homework to do?
No.
You don't get a lot of homework in primary school? Yes. So you prefer that here? Okay, I just want to give you a task to accomplish over your March holidays. Okay, so this is what you can expect over your March holidays. It's class by science rep, let's check.
His name is Jack.
Jack feels like my unwilling science rep.
No, I'm very willing.
Okay, Jack, I promise you at the end of this year, you'll get proud. Y'all remember this, huh? Okay. Okay, for your holidays, I just want to preempt you early. For your holidays, you'll be getting your ATT, Authentic Transfer Task. Okay, you get part 1 of it. This is an individual task. Okay, as I promised, Jack, I will be the one counting the groups. And Jack, you have a final look. Okay, at the groupings. You see like any potential conflicts, right? You let me know. Potential people that may fall in love with each other, so let me know. Okay? Then I need to split them up before any sparks fly. Check, you don't try to play Cupid and start to. I tell you, at this age, right? For a moment, I thought you were going to choose your own partner. At this age, you all don't go and find relationships, still very young, okay? I've never seen any couple from JH1 last up to JH1. Okay? Focus on your learning for now. When you all go to the upper senior high side, right, I don't really care already. Okay, second thing that I expect you to do is I want you to start organizing your science file. Okay, there's nothing much at the moment, right? But I just want you to quickly, before we reach the year end, then you realize things are here and there everywhere. And you have nothing much to revise. Okay? So this one I need Jack's help. No, Jack, you're not doing the science file check. Okay, Jack, can you collate a list of worksheets that we have so far and that we've done so far? Okay? You collate a list, then you send to me, I double check, then after that, once clear, you can send to the class chat to let them know the list so that they know what to include in the file. Okay? Do you want to go the extra mile? Okay, so then you go the extra mile, then you help everyone. Yeah, I show you the definition. You create a cover list. Okay, last time your science file got this one, right? Yeah. Okay, so you create a cover page for everyone. So the cover page, right? I let you decide what you want to do. So it's like, for example, signs, file, worksheets. Okay, you can decide you want to create pattern now, also can. Okay, but then there should be a table. Then there should be for number of worksheets, right? Then after that, your friends can have spaces to label and put in what the worksheets they should have.
Okay, so can I appoint Cory as my assistant science rep?
Who?
Cory.
Who is Cory?
Cory. Why is he called Cory?
You want?
Because he want to be Cory.
Oh, you are intern. Okay. So sorry, are you delegating the work to intern or are you collaborating?
Collaborating.
Okay, that sounds good. Okay. Can I? Okay, so your science file is the next thing. Okay. Then I'll try my best next week to return all the practicals that you've done. Okay, I would like you to revise them. Okay, for your upcoming practical test in term 3 week. Term 2 week 3. Okay, it's going to take place in term 2 week 3.
Wait.
Okay, so this will be likely your holiday homework. You have your diary or anything. Can you take down this holiday homework? Yeah? Right?
The practical, the term 2 week 3, right? Is it on Wednesday?
What's the date? The date. Can you just calculate check the calendar?
I think it said Wednesday, but I want to double check.
Okay. Do you have a diary or anything? Please take down the holiday homework. Yeah. Brian, it's on Wednesday, 5th April. Hey, why all the girls and some boys got a proper system of taking note of homework? Then some boys don't have any system.
Who needs the system to take down your score?
How do you all keep track of homework? Is it you all prepare your friends to remind you in the class chat?
God gave you a brain for a reason.
I was added into one class chat, I can't remember 5 or 6. Every night or something, will ask for homework. Oh, okay. Oh, that means 1 or 6. Every night someone will ask, hey, what's the homework? I don't know, they added me in there. Then I just keep quiet. I'm not sure if they know I'm inside. Oh, it's not official, I know. Oh, so unofficial is just you, is it? Okay, well, you all have fun, you all don't hurt each other's feelings, can? I know last year there was a case that was brought up all the way to year 8, principals don't know. Because within the class chat, the unofficial one, friends became enemies, classmates started bullying each other. I tell you how they bully each other. You all like do this, They create stickers, create memes. Okay. Then it goes in a class chat, then some people's feelings were hurt, then they fight back, then they fight in the chat, come to class, also fight. Then it became very nasty. The whole class phones were confiscated. The whole class's phone was confiscated. Okay, so while you have these chats, you try to be harmonious with each other, okay? Spread good things, not bad.
Yeah, for real, and then you keep editing them. Even worse.
Yeah, exactly.
Okay, so if you all know who you are, if you are the ones doing this kind of thing, you try to spread positivity. Okay? I tell you other stuff that they do. So for example, they see one boy, one girl from the class together during recess time, right? Then after they take a photo, then post in the class chat.
I told you guys.
So you don't do that, Okay? You're just let things happen naturally. Okay, just let things happen naturally. Go and do this kind of thing all that you Okay, got a homework for holidays? Check, you help me take note, just remind when the holiday comes. Yeah, so this is, I don't need copy checks, but let's check your homework. Oh, okay. Taking part 1, I'm going to announce next week. Okay? It's a rather simple task. I just want you to go out into the world, take some photos, Everyone's so awesome.
Hey. What kind of ball? Minecraft?
Okay. Guys, it's like 8:15 only. Yeah, how about it? Okay, so the rest of today's lesson, remember I did this with your class. I think we did. Okay, but I'm going to introduce you some. Okay, this is rather mathematical. By science, you notice by now that we do quite a bit of math. Okay, so I just want to run through with you. You've learned about significant figures, decimal places, right? So I want to make it clear when you need to round off to what. Jack, you got down your stuff already? Okay. I like teaching JH1 because as I teach y'all over the weeks, I watch y'all grow up. Some grow taller,
Some grow shorter.
some I especially am very thankful when I get to teach y'all up to JH3 and 4. So usually if I get to teach the JH1, very likely I will follow your batch all the way until JH4s. Yeah, so I've got currently the JH4s, I managed to teach around 6 students from JH1 all the way to JH4. I watch y'all from wee little tiny little beings, right, down taller than me. Yeah, so I hope I have that chance to do that with y'all. But when you reach the JH3 and 4 side, I'll mainly teach y'all biology. My chemistry and physics cannot teach y'all up to that high level. No, can is can. It's just that I need refresher. Yeah, I took subjects all the way up to A level, so I have some background. Okay, so today we're going to do some data processing. We call it data processing because you realize, I didn't complete with this one. You realize that as you're doing your science and you collect data, sometimes when you punch in your calculators, you end up getting quite long decimal places, right? It goes on forever. So when do we round off to certain decimal places or significant figures? That is the scope for today. Okay? That will come in especially useful in, for example, next week's practical. When we go inside the lab and calculate density. When do we round off to certain decimal places or certain significant figures? Your math teacher is Mrs. Xia? Okay, so Mrs. Xia has taught you about significant figures. Sorry? Oh, Mr. Lim. But Mrs. Xia is your math teacher. But Mr. Lim? Okay. Oh, okay, but Mr. Lim teaching you about significant figures in decimal places. Okay, where are you all into that topic? Finish already, okay. So, I need you to draw on that aspect of math into this part of science. As you go up the levels, you'll find that things you learn in math can be used in science, things you learn in chemistry, biophysics can be applied across each other. So I encourage you, when you go to JH3, take all 3 sciences. Okay? No. It is a lot of students take all 3 sciences. Yeah? When you go to the JH3 side. Okay, so I encourage you to do that because when you take 3, you will see how they intertwine each other. There's no harder science. There's no harder science. Okay, in my opinion, because my brain works differently, I take a while to interpret things when it's abstract. So physics is a little bit tougher for me. Yeah? But I did the best in physics. But my biology was the worst. Okay, data processing. So let's introduce that. So I need to recap some things with you. When you are for this particular section of which is the last section, I want you to be aware of when you need to round off certain decimal places and certain significant figures. Okay? So we look at these 2 statements. Okay? These 2 statements go something like that. Number 1, the population of our city is 157,872. Okay? But it is an imaginary city, yeah? Not Singapore, because you all will know that Singapore's population is very higher. Next, the number of our registered voters as of January 1st was 27833. This is is of another imaginary city. Which of these will you justify as dismissing immediately? Meaning to say, which one of these two statements you feel, no, you're not so confident about the number. Okay? Okay, I'll let you think for a while. Okay, as you think about which statements you feel, okay, you won't be so confident in the numbers that's presented here. Think of a reason why. Could it be the way we collect the data? You think that may not be so trustworthy? Could it be the nature of the number that you feel you cannot possibly get this number? Okay, Ivan. Okay, Ivan, what do you think? Between these two statements, which one do you feel personally that the number that is presented you don't quite trust? Okay, why?
Because, right, the second one is registered, so the numbers can be accurate.
Okay, the second one, the process of it was required, you required people to actually go there to register, so you feel it's not accurate. Okay? So why the first one you want to dismiss?
Because people can just accept and give without the government knowing.
Oh wow, that was the most crude answer I've ever heard.
Ever heard of illegal immigrants? Black children? Don't think that's the wrong way.
Ivan, okay, but there's nothing wrong with what you just said. It's just that I've never heard students just say it blatantly. Okay, Ivan said that. Okay, Ivan, I show you another way to phrase it. Okay, Ivan said that, we have, in this population, there could have been unregistered births. Okay, and unregistered births could have led to this population number being not so accurate. Okay? Yes? Okay, sorry, let's listen. Olivia, yeah? Okay, yeah. Okay, see, you think 2 is less relevant. Why? Oh, okay. You think here children can't vote. Okay, they say here the number of registered voters as of January 1st of 27833. Okay, I guess if the government is trying to find out how many people there are in Singapore and they use this number, you're right, definitely won't be relevant. So we see sometimes the data we have, whether it's relevant or not, depends on the context we're in also. It also depends on whether the data, you can collect it in full. Okay, any other factors that may affect whether these numbers are accurate or whether you feel that you want to dismiss them. Yes, Brian, you want to think through what you want to say before it comes out your mouth. He looks like he's going to say something as crude as Ivan. Yes.
Illegal immigrants.
Legal immigrants. Okay, so kind of similar. We could have immigrants that did not register and it could not have been recorded in this number. Okay. Okay, anything else? Yes? Yeah?
There was like no date, so you don't know when the population...
Okay, there's no date either. So, we say the population of this, of the city is this number. Actually, when was this taken? Because a minute later, a new baby could have been born. A minute later... Exactly. Actually, I think there are some statistics online that show the numbers changing constantly. Yeah, yes. Yeah, every second there will be people passing away, coming to this world. Numbers constantly changing. So, when did this happen? This is a snapshot. Why are we looking at these two statements? Because in reality, the data we collect are subject to a lot of these factors. The context of when we are taking the data, okay, the timing of when we are taking the data, the purpose of when we are taking the data can affect whether we find these readings accurate or not. You find that sometimes when data isn't so accurate because all these things affect it, that's when we may want to round things off to a certain decimal place or significant figure. If, for example, you cannot really tell in this precise moment of time whether this number over here is going to be very accurate. Because sometimes what we do, we round it off. Lor. Yeah, you notice sometimes when government gives statistics, they won't give you statistics down to the last digit. They tend to give you statistics that go something along the lines of approximately 500,000 people have diabetes in Singapore. Rather than, in Singapore we have 500,230 people that have diabetes. That number will change according to the context, timing, purpose of whether we want to use the data for this or that. Yeah? So that's the reason why we want to round things off to a certain decimal place or significant figures, because it gives us at least an understanding of the number, the scale of it, but without delving so much into whether these things affect the data we have collected. Inside the lab, we also round things off to certain decimal places or significant figures, because in reality the calculator you use will produce a lot of numbers. Some of them are not so relevant to our purpose. Not so relevant in this context where so many numbers after all. Okay? So that's why we do what we do. You will find that when we look at numerical values in your textbook and inside your worksheets, there are two different kinds of numerical values. The first kind are exact numbers. I'd like to give you some exact numbers. So I'll give you an example. For example, let's say I ask you to take 3 readings during your practical. That is an example of an exact number. I'm telling you to take 3 readings. Okay? So if someone asks you to take 3 readings, it's an exact number. Unlikely for you to find any decimal places here and there. Let's say I have 3 blocks or 3 apples that I'm asking you to safe keep at home. That's an exact number, I'm telling you. You can't measure this, right? I'm just telling you there are 3 apples. There are 3 experiments you need to conduct. There's no measuring instrument for you to measure that you have 3 apples, 3 experiments you need to conduct, right? These are exact numbers that you come across inside your papers. For example, another example, sometimes if you read a passage, they may say there are 2 friends that are running at a certain speed. These 2 friends are just 2. It's not like I have any instrument to measure that there are 2 people. On the other hand, there are numbers that are measured in nature. We call them measured data. These measured data requires instruments. And this is our scope of our lesson so far. We've been using rulers, vernier calipers, digital screw gauges, mass balancers. These are all instruments that help you measure a certain quantity. You find that when you use measuring instruments, that's when you encounter a lot of decimal places. Right? Because each one of these instruments have their own precision. I test you again. For vernier caliper, the precision is 0.1 mm. Numerical value with its units of a screw gauge. Okay, it is 0.001 mm. Don't worry if you forget, because you really just need to read out the reading. Yeah? But if you can remember, please way faster. Okay? So, now let's focus on this part of the numbers that you will deal with. When do we round off to certain decimal places or certain significant figures? Okay. From now onwards, if we ask you to do calculations, we expect for you to round off to 3 significant figures in certain contexts. You all can round off things to 3 significant figures? Okay, so if I give you 5.643, what would it be if you round off to 3 significant figures? 5.64. Oh, sorry, there's what? What did your math teacher teach you? Oh, sorry, your math teacher taught you this, is it? Then after that, KSF. Okay? So you learn this correctly in math, huh? Okay, so three significant figures you understand. So when do we round off your values to three significant figures? I'm going to give you some examples of when you might want to round off. Okay? Can you go to the page of your textbook where you can find a table that shows you derived units? Can you roughly remember which page that is? Okay, there's a page that shows you SI base units as well as derived physical quantities. Which page is that? Okay, some of you have found a page. For those that know the page, you can guide your friends. I didn't know you can make that sound. Come up to your mouth.
Each one can.
Oh,
Each
one can make any sound. Each one always making sounds.
Each one, have you heard of music program?
Okay. Okay. You see, are we on the page? Page 56. Do you see that there are base units? Do you see that there are derived physical quantities? Yeah? Oh, I just realized all of your blank on the physical quantities. Okay, so on this page, so far, this is what we've been dealing with, right? I asked you to measure certain base units. You'll be measuring length, mass, next week volume. But notice we haven't much been working and multiplying these different base units together. You learned in primary school before, right? Speed. Speed is a measure of distance against time, right? It's a measure of how much distance you travel in a certain amount of time. Notice that when we look at speed, there are two different units we're working with. Yeah? But so far, we've only been working with one kind of unit. Every time you measure something, you either measure mass or length or time, but we haven't quite worked with them intertwined with each other. Okay? So these are base units, what you've been using to measure, what you've been measuring using instruments. However, soon, we will be getting you to do calculate derived units. One of the derived units that you are aware of, that I think you learned in primary school, is area. Learned before, right? When you multiply two different lengths together, you get area. For example, if I ask you to find the area of a square, I give you 2 times 2, you can measure area, right? Okay? But the unit will change. You know what's the unit for area? If it's cm, you get? Okay, the new unit is cm squared, correct? And then the multiplication is 4. Okay? Notice that this is no longer, it is not a base unit anymore. It is what we call a derived unit. And I'm going to show you some of examples of derived units. So for example, you have meter square for area, meter cube for volume. For speed, again, notice we no longer use the slash sign. We use the s to the power of -1 now. Okay, that's speed. The last one is density. These are examples of derived units. So what are you doing? Yes. Okay. You told us when we learn luminous intensity, is it? I don't know in physics if you will. In biology, you may work with intensity of light, but we don't really use any instrument to measure the intensity of light. Yeah, we just like a light bulb, right? We turn it more like brighter. Okay, we tend to use it when we want to investigate how plants photosynthesize. Have you seen before? Okay, so when do we round off your data to 3 significant figures? You round it off to 3 significant figures when calculating derived units. Is that okay? You calculate it when you are trying to derive a new unit. Next week, you will try this out. Next week, we are going to calculate density of various objects. Okay? So, other than measuring the mass of the objects, the volume of the objects, the next step is for you to calculate the densities of them. Okay? And that's when you are deriving a new unit. That's when I expect you to round things off to 3 significant figures. At the end of the practical next week, I will not remind you. By the end of the practical next week, I will check on all of you and ask you if you round off to 3 significant figures. Okay? So you try your best to remember. So that also means if next time I ask you to calculate volume, round off to 3 significant figures also. Okay? Okay, next, I want you to take note. So this is the first level you need to take note of. Second, you need to take note. You will do it right for final answers. Okay, you need to qualify for this first. You need to make sure that you are calculating derived units first. Second, to take note is your final answer needs to be this. Okay, why do I say that? I'm going to give you an example now. If a teacher asks you, for example, to calculate density. Okay, the teacher asks you to calculate density. What do you need to calculate density? You need mass, okay? Is there much to calculate for mass? Actually, you'll likely be measuring in the practical, right? Volume is interesting though. Volume, technically, you can measure it using measuring cylinder. Sometimes you could also calculate it, right? If you have a cube, technically you could calculate the volume, right? Are you deriving a new unit if you are calculating volume? Technically you are, right? So in this case, if you are calculating volume, you may get an answer that goes on quite long. If this is not your final answer yet, because they ask you to calculate density is the very last step, then when you are calculating volume, for example, when you're taking, okay, I'm going to do 1 times 1 times 1 times 1, right? You can leave your answer instead 4 significant figures, so that your final answer that you're going to round off to 3 significant figures is a little bit more accurate. I don't know if you do this in math or not. Yeah? In math, you don't round off immediately, right, to 3 significant figures in their intermediate steps. Is that what you do? Okay, then what do you round off in the intermediate steps? 5, okay? Okay, so we don't need to go to 5. But if you go to 5, that's okay. Okay, that's okay. It's just that we don't cut off too early. Okay? Okay, so you see what we learn in math and science, we don't contradict each other. We are quite aligned ones. Okay, so this is the scenarios when you want to round up 3 significant figures. Okay, let me give you some scenarios that you do not need to round up 3 significant figures. Okay? Number 1, ignore calculating average. Don't need to round up to 3 significant figures. Yes?
So what is the average for final answer?
It's very long, is it?
What is the average for final answer?
Or like you calculate 3 densities, is it?
Yeah, that's the final average.
Of the densities, is it?
Yeah, so you will not round off or round off to 3.
Okay, that's a good question, but I would say that it's unlikely that you face that scenario. Normally what would happen is that you have to measure 3 different masses first, 3 different volumes. Then you find the average of each. Then you calculate density. Then you round up to 3 significant figures. We do not calculate density from each one of those mass and volumes. Then after you take an average of the 3 densities. We don't do that. Okay? So when calculating average, I'll give you an example. Let's say you're asked to measure mass. Okay, so mass, you're asked to measure mass. And then after that, okay, it's in grams, right? And then let's say you have 2 grams, 3 grams, and 4 grams. Okay, and you take an average of this. What's the average? 3, yeah? Is it 3? Okay, well, then you change the number so that you get more decimal places. 1. What do you get? Something longer? What is 4 plus 3 plus 1? 7. What's 7 divided by 3? Oh, what's 8 divided by 3? What? Okay, then your math teacher teach you a dot, is it? Okay. So 2.666 continue on, right? Okay, again, you see what I've done, huh? This is not a good example. You should always explain whatever you're doing. So I should write average mass equals to, okay, 2.666. Your natural instinct may be to round it off to 3 significant figures because you're doing a calculation. But have a look up. Actually, you're not deriving a new unit at all. All of this was in grams, right? It was 1 gram plus 3 grams plus 4 grams. They're all the same unit. We are not calculating or deriving something new. We are just working with our base units. So in this case, what do you round up to? You don't round up to 3 significant figures. Okay, this is what you round up to. I think I'm a little bit inaccurate. I did not tell you what instrument we are using. Let's say we are using a mass balance. And the mass balance, the significant figure, the decimal place goes up to, I think, was it 2 or 3? I think it depends on your measuring your mass balance. Some mass balance go up to 3 significant figures. Sorry, some mass balance go up to 3 decimal place up to. Let's say our mass balance goes up to 3 decimal places. Okay? That means to say, my workings will be slightly different now. It will be 1.000 grams plus 3.000 grams plus 4.000 grams divided by 3. Okay. So, what do you round off to? You're not deriving a new unit, but you need some calculation. You round off to the precision of the instrument. So what's the precision of this instrument? How many decimal places? 3 decimal places. So you will round this off to 3 decimal places. And what would it be in this case? 2.667. And then you put 3 decimal places because this is the precision of the instrument. Okay? So 2 scenarios you will see encounter in practicals and in your worksheets. One is, if you are deriving new units, you want to round it off to 3 significant figures. If you are not just taking an average, or if you're not deriving anything new, then it will be to 3 decimal places. Let me give you another example of when you may be just working with 2 different values, 2 numerical values. For example, when you use measuring cylinder, let's say you want to take a before and after volume, right? Can I give you some time to take this down first if you like to, so that you remember? Oh, I forgot to add the units. Yeah. So next week onwards, I will be checking all this up. This is what you want to practice when you do your practical. I don't don't see many people writing anymore. Okay, so let me give you another example. If teacher were to give you a random ball and then we want you to find the volume of the ball, and we provide you a measuring cylinder and we give you water. You have a way of measuring the volume of the marble, right? How will you do it? Okay, number one, you put some water first. Then you measure whatever this volume is, right? Perhaps the volume is 3.5 cm3. Then you put the marble in. And likely this will rise. Right? You measure it one more time. Maybe you'll get this time 5.0 cm3. Then if I ask you what's the volume of the marble, what will you do? You take 5.0 cm3 minus 3.5 cm3, and you will get 2. Oh, wow, my bad now. Okay, 1.5 cm3. Okay? Notice here, we are not deriving anything new. Not a derived unit, right? We are purely just working with same kind of units. Okay? The decimal place. So what do we round off to? In this particular instance, it's a very nice number, right? There's nothing much to round off, but actually, it is to the correct precision. Here's 1 decimal place. The precision of the instrument also went up to 1 decimal place. So nothing much we needed to do. But let's say if this number was something odd, rather long, then you just round off to the same precision as the instrument. Okay? So next week, this is what we'll practice, and I'm going to check once you're done with the practical. Okay? And really, that's all. We have come to the end of this particular chapter. Wow. Okay, so now, let's see how much time we have left. Hey, why I talk so much? Okay. So now, if you take out your RE, you will now see that there are some questions. Yeah, borrow from Avia. You'll find some questions now that will allow you to practice this. Okay, I would like you to complete all of it. You'll be going through this next first lesson of ours. What does this mean? Is it? Yeah, I'll go through it all. Okay, so let's look through what I expect you to complete. I expect you to complete all the pages, but you've done quite a bit already. Okay, so some of the questions that allow you to practice whatever we just talked about on the whiteboard. Okay, you go to page 3 of 4. Go to page 3 of 4. You see there's a table there. Okay, that's not so much what we did on the whiteboard, but it's just a little bit of math for you to practice significant figures. You go to the last page, is when you do some of the practice. Question 9 asks you to calculate the average. They ask you to calculate the average. With what we learned today, I'll leave you to decide what to round it off to. Okay? Then we'll check again next week. You go to question 10, they give you some sample data, then they multiply with each other. I'll leave it to you to practice rounding off to 3 significant figures. Okay? Next, we go back to question page 2. I think you may find it challenging to do question 6. Okay? Can everyone just quickly read question 6 first? Can you just read question 6 first? Done reading question 6. You find question 6 gives you a table. Right? Then it asks you to state the physical quantities that the student is going to measure. What is the SI unit? And then it asks you to justify what are the parameters you want to use to measure it. Okay. First, physical quantity. We expect you to read the paragraph and know what we are measuring. Number 2, the base unit. You can refer to your textbook, that table, for what the base unit may be. Last one, apparatus with justification. They are asking you which apparatus you want to use to measure what she wants to measure. Remember, when you're measuring length, you use a lot of instruments, right? You use a screw gauge, you can use a caliper, you can use a ruler. So I want you to write down in that box which one of the instruments you want to use. And you justify. Sometimes we use a ruler because it's really big. Sometimes we use certain instruments because it's really small. Right? So I'll leave it to you to justify why you want to use which instrument. Okay? Measure time. Technically you can use your own watch, stopwatch. You can use your own one. You can use the stopwatch from school. So many different instruments to use. I want you to just justify one. Okay? Okay, with the leftover time, you may work on your worksheet. Do as much as you can before we go through it in the next lesson together. Is your P after this? Okay. Okay. Then your teacher is Miss Tan. Salam. Sabah. No, I'll let everyone change together. No. I mean, I'll let everyone leave the classroom. If you go into individual cubicles to change side by side. Okay, this is my LA not good. How should I phrase this better? Yeah, okay. What would Mrs. Chandra say? I would release all of you at the same time to go and change. Yes, yes. Right, okay. So, if someone asks you SI unit, they're asking you for what that unit, SI unit. Yeah? So that means you only write grams if they did not ask you to write SI unit. On the right, then at the end of the day, when you use the methods, what will come out to you? Right? Yes, what they are trying to assess or understand all of this. Maybe, when you're measuring math, what's the SI unit? And I'm glad you're aware that in this context, you will not be using SI unit, you will be using conversion of power.
We're measuring
do I write the SI unit or do I write the unit that I'm going to use to measure? No, or do I use the unit that the measuring instrument will show? But write the SI unit. Okay? I know that the measuring instrument that you're going to choose may not show it. Right? That's fine. You write your justification why you're going to use that measuring instrument anyway. Okay? Is there a page that shows you all the different things you can use to measure? Which one is most appropriate? Okay, that's all for today. So thank you, super for me.